Okay, hopefully this helps. I did recently do these kind of problems in a master's course with completing the square. An example would be if you have x squared plus 10x minus 39 as your quadratic, you could rewrite that as x squared plus 10x equals 39. Okay. In order to do this, you must first split this term, okay? So that's got to look like 5x. And so when we're drawing out the square, and excuse me because I'm just doing this with one hand, is this first square that represents x squared is x by x. Okay, so that represents x squared, the first term. Okay, now if I split 10x, if I think about it, what I'm going to do is I'm going to make this worth 5. Okay, and so the area of these two rectangles here would be 5x. So here we have x squared. This is 5x, and that's 5x. So far what we've represented is x squared plus 10x. And this equation tells us that equals 39. So this is really an area model. And what this is saying is this shape equals 39 units squared, okay? So if I complete the square, I'm going to draw the square here. That makes this now a square. And we know how long each side of this square is. It's 5, okay, because it corresponds with these. So that means the area of this little square is 25. And if the area of these original parts was 39, that means that the area of this whole square now is 39 plus 25, which is 64. So the area of that whole square is 64 square units. So what does that mean about the side length? Well, the relationship between the square and its side length is the square root will give you the length of the side. So square root of 64 is 8, and that means that this side of this original square is 8 units long. And what we can do to solve x is on the other side, if you look, it shows us that x plus 5 is going to equal 8. And if x plus 5 equals 8, we could recognize that x is equal to 3. Okay, so that's one solution to this. The other solution to this equation is going to be because x can also be, what's going to happen is, if we remember, in reality, this side length couldn't be negative, but a square root itself can be negative, right? So the square root of 64 is also negative 8. So that means that there's another solution to this where x plus 5 equals negative 8. So if I take away 5 from both sides, I see that x is negative 13 as well. So this quadratic has two roots, 3 and negative 13. And I just pulled up Desmos on the computer before I did this just to double check my solution. And it shows me that there, the solution is negative 13, and there, if you can see it on this, the solution is 3. Okay, so I hope that helps. And if it didn't, ask a follow-up question. And if I can't answer that question, I will pass it along.